Welcome back to this in-depth devlog of this new game that I'm working on. Last time I implemented dropping the balls from a path above the pit, and this time I'm focused more on the combat that happens when the units enter one of the rooms in the dungeon. I took my inspiration for this part from Loop Hero. You have two sides, and the units on each side just randomly attack units on the other side until one side is dead. And the combat is based on attack animation loops. So whenever an attack animation finishes, then the creature attacks. And then it loops back to the beginning of the animation and starts again. So here's what that looks like in this game. So you've got the priests on the left and you've got the goblins on the right, and they're just sort of punching each other, and then when their health bars go to 0, they die and are removed. In order to test this out, I added some tests in GD Unit 4. The test is using a scene runner, which is a construct in GD Unit 4 that runs a scene, as opposed to just testing a single class or something, which is what I often do. So my first test just makes sure that you can add and remove units from the room. The second test actually runs combat and makes sure that the signal combat finished is emitted at the end. And the third test makes sure that when one unit attacks another one, the appropriate amount of health is lost based on their attacks. These tests were a bit of a challenge to write because I haven't worked as much with Scene Runner, and at some point I'm going to make a tutorial for Scene Runner, but I'm still figuring out all of the nuances. So you'll notice that there are no assertions in Start Combat. For this particular test, I don't need any assertions because if the signal is never fired, then it will tell you that that signal was never seen, which counts as a failure. So if I go into the room class and just return before we can emit combat finished, and then go back to the test and run it, it timed out after 2,000 milliseconds. Another useful thing I learned is that GD Unit 4 can detect when you remove a child node from a scene but forget to free it. One thing that I had to change in the course of implementing the rooms was to break up the unit class into unit and unit attribute. And the reason for this is because resources in Godot by default are shared between everything that uses them. So if you create multiple priests and they're referring to the same resource, and then you change the HP on that resource, it's going to change the HP for all the priests. So I've split up units into unit attributes, which contains the information that's common between all of them, and then unit, which references some particular unit attributes, but is a specific instance of that unit and can change without affecting all the other units. And the unit class is now what has a bunch of useful functions, such as taking damage, or figuring out which way the unit is supposed to face in combat, or calculating how fast the animation needs to play in order for the attack speed attribute to be accurate. And now this priest resource here is unit attributes rather than a unit. Let's talk a little bit about how the combat room works. In the combat room, units are represented as avatars that are placed along one of two curves. In the scene view, you can see that we have room, we have a heroes faction, which is a path 2D, and we have a monsters faction, which is path 2D on the right. The battle avatar scene is a path follow 2D node with an animated sprite underneath it and a progress bar serving as the health bar for the moment. This is really convenient for distributing units in the room. So if we go to the room code and look at redistribute units, this is the function that decides where all the units are placed. And all that I have to do is iterate over the avatars underneath the heroes and monsters faction nodes, and then just set their progress ratio to be some fraction based on the number of avatars in that node. So what that means is, for example, if there are two priests, if you look at this left path, they would be distributed at 1/3 and 2/3 of the way along the path. That's what progress ratio means. It's the percentage of progress along the path And this is much easier than having to calculate the exact position of each unit individually. I think one of the big lessons that I've taken away from this project so far is just how versatile curves and the path node is, the path 2D node. So I would definitely say that if you're looking to get better at Godot 4, you should learn how to use curves and learn how to use paths, because they have a lot of useful applications beyond the obvious one of having an object follow a particular path. Whenever we add a unit to the room, it's going to create a battle avatar and add it to the appropriate parent node. So heroes is a reference to the heroes faction node, and monsters is a reference to the monsters faction. So it sets the battle avatar's unit to be the unit you pass in, and the battle avatar has a signal called attacked, which is released whenever you call the resolve attack function. So this signal is bound to the resolve attack function here. And what resolve attack does is it figures out which units can be targeted. It picks one at random, and then it deals damage to them depending on the attacker's attack points. And then it checks if combat is finished and emits a signal if it is. I have attacks being resolved directly between the unit classes as opposed to between the avatars, because the avatars are just supposed to display information. They don't handle the actual logic. And the battle avatar is listening for the signal. So you can see right here, unit HP changed is connected to update HP, which will either destroy the avatar if the health is 0, or it will update the health bar, which is the little green bar above the avatar that displays its current health. The way that the program currently determines whether combat is finished is it looks for units in each faction, that is, avatars under the hero node and avatars under the monsters node, and it checks whether the units corresponding to those avatars have any health. And if both sides have at least one avatar with a hero that has HP, then combat is not finished. And actually, now that I'm saying this, I just realized that it should be the opposite, because combat should be finished if there are no heroes alive and no monsters alive. And that's a little troubling because my room test was behaving properly. Okay, I think I figured it out. The combat finished signal was being emitted pretty much immediately because it was checking that there were heroes and monsters alive, and so the test passed. After inverting the results, however, when I go back to the test and run it, it fails after the default timeout of 2,000 milliseconds. However, if I increase the timeout period to 10,000 milliseconds and run it again, so we can watch as they attack each other, they have 10 seconds to finish the battle. Okay, and it timed out after 10 seconds, actually. So let's up the timeout to 20 seconds. All right, they're fighting again, losing health. They have a lot of time now to finish this battle so that the test doesn't fail. And there you can see the test passed because the signal was emitted. Anyway, going back to the room code, the one thing I don't like about this is combat finished function, aside from the fact that it was previously not working correctly, is that it's kind of ugly because when units die, their avatars are deleted. So combat could be considered to be finished when one side has no avatars left. However, the avatars are deleted using queue-free, which doesn't resolve immediately. But I'm checking that combat is finished right after the target takes damage. And you can imagine if I were to add some animation to when the target dies, I would need to take that into account as well. Probably I would need to give enough time for the death animation to play before closing the scene so that it's not cut off abruptly. Right now, this is just kind of a hack where I'm checking, are there units and do they have positive HP? This will need to change at some point in the future, or perhaps I'll need to change when it is that I'm checking for combat to be finished. One really useful thing I learned while working on this part of the project is that Godot 4 has a different syntax for setters and getters. So instead of what I did in the previous video, where you define a setter function and then show how the function works separately, you can actually just put the set function right underneath the declaration of the variable. which saves on space and saves on having extra functions just lying around. So you just have the variable, you have its initial value here, which is null in this case, and then you do colon, and then right under that you define a setter, and you can also define a getter right there as well. Each of the battle avatars has a set speed scale function, which changes the speed scale of the sprite. So this is useful so that you can speed up how fast the battle happens if the player doesn't want to wait through very long animations. But while I was implementing this, I ran across a difficulty, which is that in Room, so Room is actually an animated sprite 2D class, which is the one that has the set speed scale method. I ran into a problem because Godot 4 would not let me override the method. So if I comment this out, you can see it says this method set speed scale overrides a method from native class. This won't be allowed. So this is slightly annoying, but you can actually get around it by just adding a warning ignore, and then it doesn't care that you're overriding this method. So you can see this, I've just changed the way that set speed scale works so that it does what it originally did and just updates how fast the animation is playing. But then it also goes into all of the avatars. Remember the Room class, the way it looks is that you've got your heroes faction and monsters faction nodes. So it goes into the avatars that are underneath both of those nodes, and that just calls set speed scale. And that's basically how my combat rooms work right now. I'm sure there are improvements that can be made in the future, but I think the next step in this project is to find a way to get the units from the pegboard, where they are represented as a ball falling through the pegs, and then get them from there into the room so that they can start fighting.